Are you preparing for a Java interview and wondering where to start? Welcome to what we believe is the world's best Java interview guide. This is packed with carefully selected questions, real code examples, and practical insights. I'm Ranga Karanam. I'm the founder of In 28 Minutes. With over 1 million learners across the world, I've helped thousands of developers master Java and succeed in their careers. I've conducted more than 100 technical interviews, and this guide is a direct result of that experience. It's designed to help you understand what really matters in interviews, from fundamentals to real world scenarios. And what's the best part? We have created a complete companion website with every single question and answer available at interview.in28minutes.com. You'll also find the link below in the comments. Whether you're brushing up for an interview or strengthening your Java skills, this guide is for you. So what are we waiting for? Let's get started with the Java interview guide. And instead, let's talk about some of the major Java versions and their most important features. Let's get a 10,000 feet overview of some of the most important features that are released in different Java versions until now. Let's start with Java 5 or J2SE 5.0. Enhanced for loop. Before enhanced for loop, you needed to do something like for int I is equal to 0, I less than size of the array, I plus plus, and then you need to loop around the array. However, from Java 5, you have enhanced for loop. If numbers is an array or numbers is a collection, a list, or one of the collections, you'd be able to directly loop around it without needing to create a variable like I. Next, generics. You can create a generic class like hash map of key and value. Now, you can specify what should be the type of the key. It should be a string or it should be an integer. And you can also specify the type of the value. It should be a specific object type. It should be some other value. You can specify the type of it in here. So generics enables type safety in collections, and you can create your own generics as well. Generics can not only be used on classes, but also you can have generic methods and generic interfaces as well. Generics makes it easy to write type-safe code in Java. Next, enums. Enums provides a type-safe way to define constants in Java. Let's say you want to create something which only can have a specific set of values. That's where you can create an enum. Over here, we are saying enum season can have these values. This would avoid the need to have hard-coded strings or hard-coded values. It provides a type-safe way to define constants. Next is auto-boxing. It automatically converts primitives to wrapper classes and the reverse as well. So you can do integer is equal to 5. 5 will be converted into an integer. You can also do the reverse. You can say int I is equal to integer. This would convert a wrapper class into a primitive. Important features in Java 5 include enhanced for loop, generics, enums, and autoboxing. Next, let's move to Java SE 7. One of the key features which are introduced in Java 7 is try with resources. This automates resource management in try-catch blocks. You might forget to call br.close. You might forget to close the buffered reader in finally. That's where automatic resource management is introduced. You can say, I would want to manage this specific object. And you can specify which object you would want to manage in the try itself. What would happen is by default in finally, br.close would be called. How is it possible? This is because any class which you can use in here should implement an interface called auto-closable. And in the auto-closable interface, there is a method called close. So what Java does is when you write code like this, it would automatically add br.close in finally. So this would automate resource management in try-catch blocks. Next is strings in switch. Earlier, you cannot use strings in switch statements. Starting Java 7, you'd be able to write cases making use of strings. Let's now move over to Java 8, where we introduced functional programming. You can create lambda expressions. So this is an example of a lambda expression. Over here, we are creating a function. If you look at this specific method, it's returning a function back. What is the type of the function? The function is of the type predicate, and the type which is being used by the predicate is course. So we are returning an implementation of the predicate interface, and this is the implementation we are returning back. So lambda expressions were introduced in Java 8, which allow you to write concise, functional style code. You don't need to specify input parameters. You don't need to use the return statement. You don't need the boilerplate. You can easily create functions. Having lambda functions alone is not sufficient. You need to be able to use lambda functions and process a stream of values. That's where Streams API comes in. It provides a powerful way to process your collections using lambda functions. So you can easily convert an array, a collection, into a stream. And you can apply a number of functions. Over here, we are applying a number of lambda functions using different methods that are provided on the stream. We are making use of map method in here. Map is an intermediate method, intermediate operation. The map operation returns another stream. That's why it's called an intermediate operation. The toList is called a terminal operation. It would convert your stream into a list. Over here, we are using list of string. So streams and lambda expressions enable you to do functional programming. You can create higher order functions, functions which can accept a parameter which is a function which can return a function as a return value. These are what are called higher order functions. And in functional programming, we are writing immutable code. You would see that you don't have variables like sum, which is being incremented in each loop. Most of the code that you would be writing in functional programming is using immutable variables, variables whose values do not change during the course of the program. So Java 8 is one of the key Java releases where functional programming was introduced. You can use streams, lambda expressions, and related concepts to do functional programming in Java. Java 9 brought in modularization. JDK was split into modules for better scalability. In addition to splitting JDK into modules, you are also provided with facilities to split your applications that you are building into modules as well. And JShell was added in. It's an interactive command line tool for testing Java code. You can directly type in a statement like this, and it would return the output back. What is the result of this specific statement would be shown to you. From Java 9, let's move to Java 10. One of the key features which was introduced in Java 10 is local variable type inference, VAR. It allows type inference for local variables. Earlier, when we defined new array list, something like this, you need to specify a type on the left hand side. Over here, we are saying this is array list of string. However, with local variable type inference, if you are creating this as a local variable inside a method, then if you just say new array list of string, Java will be able to identify that this is of the type array list of string. So you don't need to repeat the fact that this is an array list in here. If you are creating a map like this, the map would be inferred as hash map of integer comma string. So the type of your variable is automatically inferred by the compiler. Java SE14 introduced switch expressions. This enables switch to return values, further reducing boilerplate code. So over here, the switch expression which we are creating, the switch is on a enum. Day is a enum, and we are seeing if it's Monday or Friday. Then we are returning weekend is near. Otherwise, we are returning regular day. The interesting thing is the fact that this switch statement is returning a value back, and we are storing it in a result string variable. So we are talking about switch expressions which were introduced in Java 14 that enable switch to return values. This reduces boilerplate code. In Java 15, text blocks were introduced. You don't need to write strings with escape characters and things like that, with new line characters and things like that. you can directly put your string. For example, you want to create a JSON. You can put the JSON and wrap it in 3 double quotes. So 3 double quotes at the start, 3 double quotes at the end, and this becomes a text block. This makes it easy to work with multi-line strings. Java 16 introduced pattern matching with instance of. So if you have instance of a specific type, earlier you need to first check instance of, and then you need to create a variable of that specific type. Over here, we are combining both of them into a single statement. You can see that this would not only check if object is instance of string, but if the object is instance of string, it would also create a variable called s. And you can use this variable s directly inside the block. There is no explicit cast which is needed. Java SE 16 also introduced record classes. This enables compact syntax for immutable data objects. This would create constructor, this would create getters. You'll also get methods like hashcode, equals, toString, and a lot of other features. From Java 16, let's move to Java 17, which introduced sealed classes. It provides controlled inheritance for your class hierarchies. For example, if you define a sealed class vehicle permits car, truck, and bike, then only these 3 classes are allowed to inherit from vehicle. So only these 3 classes can extend vehicle. And when you are extending vehicle, you can also specify how the further subclasses can be created for you. For example, car extends vehicle and it says final in here. So there is no further subclassing allowed for car. However, class truck extends vehicle. What we are saying in here is non-sealed. Basically, what we are saying is truck can be extended freely. We want to unseal it. We want to make it non-sealed. On the other hand, bike also is extending vehicles. However, we want bike to remain sealed. This only permits electric bike to extend bike. And we are also making electric bike final. That means nobody will be able to extend electric bike further. So sealed classes allow you to control inheritance of your class hierarchies. In addition to sealed classes, you also have sealed interfaces. Even interfaces can specify which classes can implement that specific interface. The next Java version we are going to talk about is Java SE 21. It brought in a major feature called virtual threads. It improves concurrency with lightweight threads. The earlier versions of Java use something called platform threads. Whenever you create a platform thread, a OS thread is created in the background. Whenever a platform thread is waiting, an OS thread is also waiting. Each OS thread needs a lot of memory, and therefore you can only create a few thousands of OS threads on a single JVM. So this means that if you are using platform threads, your scalability is limited. However, Java brought in this new concept called virtual threads, where virtual threads are no longer linked directly to an OS thread. A single OS thread might be used to run thousands of virtual threads. And therefore, you can create millions of virtual threads without a problem. So virtual threads help you to improve concurrency with lightweight threads. In addition, Java 21 also introduced sequenced collections. There is an interface called sequence collection which extends collection and which provides methods like add first, add last, get last, remove first, remove last, and reversed. What these methods do should be really clear from their names. And the interesting thing is interfaces like list and set also extend sequence collection. Therefore, you can do this on any list and any set. There is also a sequence map interface which adds very similar feature into a map as well. Next, record patterns. It supports deconstruction, including nested patterns. So if you have a record transaction with sender, receiver, and amount, over here we are checking if the object is an instance of transaction. And we want to automatically deconstruct into sender, receiver, and amount. So if the object we are sending into this method is of the type transaction, then it would automatically be deconstructed and you will have the values in these variables, sender, receiver, and amount. And you can use these variables directly inside the block. So you don't need to declare a transaction variable and then say transaction.sender or transaction.receiver or transaction.amount. In addition to record patterns, you also have pattern matching for switch. So you can use the record pattern kind of things in your switch statement as well. So over here, we are switching on message. You can see that the customer message interface has two implementations, text message and ticket. So if the message is of type text message, we want to get the text from it. So we can use the text directly in here. If the type is ticket, then we would want to get the ticket number. So we are automatically deconstructing the record and using it in a switch statement. So this is pattern matching for switch. In Java SE 22, unnamed variables and patterns were introduced. Let's say you have a switch, and over here, I would want to define a case string. For this case, I don't want to worry about the variable. In that kind of scenario, I can put underscore in here. Underscore indicates that here I can put in a variable name. I can put in something like str. However, I'm not going to use str. So I don't want to create a variable in here. I'll just put underscore. So this allows ignoring unused variables in code. Java 23 introduced Markdown documentation commands. Traditionally, if you wanted to write Java doc, then this is how you need to do it. You need to use HTML. So if you want to make this bold, traditional bold, you need to put it in strong open tag and strong close tag. If you want to make this italics, then you can put it in emphasized tags. However, Java 23 introduced Markdown support for your documentation commands for your Java doc. So you can use Markdown bold or Markdown italic. You can also use Markdown tables. This makes writing documentation easy, and there are also additional new features like tables. Java 24 introduced stream gatherers. It introduces new ways to aggregate stream data. Let's say you have a stream of 10 numbers, and I would want to break it into lists of 3 each. You can do that using gather function. You can specify a window size. We are saying fixed window size of 3. So the list of 10 numbers is now broken down into lists of 3 numbers each, and the last list would have just one remaining element. So gatherers, stream gatherers introduces new ways to aggregate stream data. The interesting thing to note is that the gather is a intermediate operation. It's not a terminal operation. So gather in here is an intermediate operation. In this long step, we looked at several major Java versions and their most important features. There are a lot of new features that were introduced across the last few releases of Java, and I'm sure you had an interesting time taking a 10,000 feet overview of all of these features. In this step, let's talk about the primary goals behind recent Java releases. Number one is to make it concise. The goal is to reduce boilerplate and improve readability. One of the most important features with respect to that is records. You don't need boilerplate in data classes anymore. You can just define a record like this. You have a record person with 2 member variables, name and age. You don't need to worry about creating getters. You don't need to worry about constructor. You don't need to create a hash code or equals or toString or any such methods. All these are provided for you by default. The next example we would be talking about is switch expressions. Imagine doing this code with older versions of Java. You would need to write a complex switch statement. You need to have breaks and things like that. However, with modern Java, writing this kind of code is very, very easy. We are switching on an enum called day, and if it's Monday, Friday, we are returning a specific string. you can see that the switch is returning a value back and the value is stored into result. Switch expressions are more readable and concise as well. So one of the most important goals behind recent Java releases has been to make it concise. Features like records, switch expressions, pattern matching, these make your code concise. These make your code readable. The next important goal is to make Java ready for cloud and container environments, to improve compatibility of Java with cloud native environments. One of the biggest problems whenever you're launching applications in the cloud is that you would want to launch up applications quickly. You don't want applications to consume a lot of memory as well. And that's what optimized JDK container images help you to achieve. These are optimized JDK images for containers. They have smaller footprint and they have fast startup times. In addition, Java applications can be compiled to a native image. There is a technology called GraalVM, which enables efficient native image compilation. It can further optimize your JDK container images. It can reduce your image size further and improve your startup time and also improve the efficiency of running your applications. So GraalVM enables efficient native image compilation for lightweight, fast-running applications. So the first goal we talked about is to make it concise, to improve readability of code. The second thing that we are talking about is cloud and container support, to make it efficient to run Java applications in cloud-native environments. The third important goal is to improve concurrency, to enable running of millions of threads. That's where a feature called virtual threads was introduced into Java. This enables unparalleled parallelism. You can run millions of lightweight threads efficiently. You can create a virtual thread just by calling a method thread.start virtual thread. The code to create the thread remains exactly the same. You can either implement a runnable interface, extend thread, and then you can use thread.start virtual thread to create a thread. Executor service is also enhanced to support running virtual threads. So the third goal we are talking about is improving concurrency to enable unparalleled parallelism. The fourth goal is to improve developer productivity. JShell is a REPL. You can type in a specific statement in JShell and you can immediately get the output. This makes it easy to learn Java. Simpler main without class. You can write just the main without having the entire class thing around this. So write just the method, skip the boilerplate. And you can easily launch simple Java classes. If you just have one Java class, you don't need to compile it. You can just say Java hello world.java. This would compile and run the source files directly. So features like these improve developer productivity. And the other important goals for recent Java releases include reducing startup time to make sure that you are able to launch your applications very, very quickly. Better memory management, not only to reduce the memory footprint, but also to optimize garbage collection, to be able to run garbage collection efficiently, to make sure that garbage collection does not impact the applications which are running in the background. And a very, very important goal that has remained with Java for all Java releases has been backward compatibility. This is one of the top reasons why I think Java is really, really popular. Every Java release is compatible with older Java releases. So if you have old Java code, most of the times, 99% of the times, you'll be able to run it in a new Java version without making a code change. This is what is called backward compatibility, a smooth migration from older versions to newer versions of Java. Whenever you look at Java versions, you would see that there would not be a lot of breaking changes. So for 99.99% of the application, you'd be able to directly move it to a new Java version without a problem. In this step, we are looking at some of the primary goals behind recent Java releases. In this step, let's break the myth that Java is unpopular and look at how Java is marching forward. There is a myth saying Java is old and unpopular. Java is old. That is actually true because Java is more than 3 decades old. However, it's not unpopular. Java remains one of the most popular programming languages worldwide. It has remained in the top 5 programming languages for more than 3 decades. That's quite an achievement. Even today, Java is one of the most popular choices for building modern cloud applications. Whether you're building a web application, a REST API, or you're building a microservice, frameworks like Spring Boot, Quarkus, Micronaut, which are all built on top of Java, make it really easy for you to build those kind of applications. Modern cloud applications are built using frameworks like these, and Java remains one of the top choices for programming languages. In my opinion, Java has evolved faster than ever in the last decade or so. It's doing a lot to stay modern, powerful, and future-proof. Let's look at a few examples of this right now. Let's talk about the continuous innovation in the Java ecosystem. Java 8 brought in functional programming, Lambda expressions, streams. They made writing functional programs in Java a cakewalk. So in addition to object-oriented programming, you can also do functional programming in Java starting Java 8. And functional programming has been enhanced further in the future releases of Java as well. In Java 9, the entire Java platform was modularized. You can break up the JDK into multiple modules. You can choose which modules to make use of. This would ensure that your container size is low. You'd also have fast startup for your application, and your memory footprint is low as well. In addition, you can also modularize your applications. So modularization is one of the most important features which was introduced in Java 9. Starting Java 10, Java switched to a 6-month release cycle. This ensures fast updates and quick feedback. Every 6 months, we have a new Java release. Java 11 to now, a number of efforts are made to reduce code verbosity. Switch expressions made it very easy to write conditional logic using switch cases. Text blocks simplify multi-line strings. You don't need to worry about escape characters and things like that anymore. You can easily write text blocks containing JSON files, XML files, or HTML files. Records reduce boilerplate for data objects. You don't need to worry about toString or equals or hash code or any such methods. Everything is provided for you. You don't need to worry about boilerplate anymore. Pattern matching enhances code readability and conciseness. Instead of using instance of and then defining a variable, you can directly define the variable right beside instance of. And pattern matching was further enhanced with advanced features for records, including nested record pattern matching. And starting Java 21, a very important feature was introduced into Java called virtual threads. Earlier, the threads you used to create with Java are called platform threads. These are directly linked with an OS thread or an operating system thread in the background. Creating a platform thread is expensive. So at a maximum, probably you'll be able to create a few thousand threads in a specific JVM instance. However, virtual threads breaks all those things. With virtual threads, your Java threads are no longer linked to OS threads. So you can create millions of virtual threads without a problem. And this would enable high performance concurrency. In addition, a number of enhancements have been done to make Java cloud and container ready. JDK and the frameworks have been optimized for modern cloud native applications. Constant efforts have been made to reduce the memory footprint, to reduce the container size, and to reduce startup times. In my opinion, as I said earlier, Java is evolving faster than ever. It's staying modern, it's getting powerful, and I think it's becoming future proof. There is constant innovation in the Java ecosystem. New features are introduced into Java like functional programming, modularization, virtual threads. They are changing what you can do with Java. In addition, there are also efforts to reduce code verbosity, to enable you to write readable code, to enable you to write code which you can maintain very easily. In addition, the 6-month release cycle is giving faster updates to developers and enterprises and enabling quick feedback. All these together make Java cloud and container ready. Java has become one of the top choices for building modern cloud-native applications. Welcome to this section on Java new features. We will be starting with Java's evolution. We will understand how Java continues to improve while staying backward compatible. After that, we will look at the important goals of Java new releases. We'll be exploring key focus areas like performance, simplicity, and developer productivity. After that, we will be looking at some of the major Java versions. We will get an overview of features added in different Java versions. We will look at different language enhancements. We will learn how records, sealed classes, and pattern matching simplify code. We'll also understand Java release cadence. We'll understand Java's 6-month release model and what it means for developers. Are you ready to get deeper into the release cycles of Java and understand some of the most important new features in Java? Let's get started. Thank you for joining me on this journey through this wonderful Java interview guide. This video is just a sneak peek into what we believe is the world's best Java interview guide. This guide is built from ground up using insights I have gained from conducting over 100 technical interviews. As you have seen, it's practical, focused, and created with your success in mind. Now, what if you want to go deeper? What if you'd want to look at all the 250 interview questions that we have? What if you'd want to access the complete 15 hours of our interview course? If that's the case, we have a special coupon waiting for you. Just head out to the comments or the description to grab the coupon and register for the complete course. Until I see you again, here's Ranga from In 28 Minutes signing off. Keep learning, keep building, and keep enjoying what you do.